Good morning, folks. How we doing? Wow, big day today. Last day of new material. This is it. This is it. Pretty crazy. Pretty crazy. Hope you're doing well. Sorry I'm not here. I am at state tennis, hopefully having a good time. I'll let you know. But let's dive into it. I won't take too much more of your time. Joe's getting antsy. I can see it. Joe is antsy. So let's do it. 10.5, last new material. Last new material. We're talking about tangents. Super important. Super important. Yeah, so we're talking about tangents. Good stuff here. Good stuff here. Let's do it. Oh, this isn't working. Whoa, hold on. So there it goes. Whoa, that was super delayed. All right, I think we're online now. Okay, sorry about that. 10.5, tangents. A tangent is a line, ray, or segment in the same plane as a circle that intersects a circle at exactly one point called the point of tangency. It's hard to understate how important this is for your future math. You're going to see tangent lines all up in calculus and physics and all kinds of stuff. Tangent lines are super important. It's kind of why we did this chapter, is to get to something like this, okay? So tangent lines, that's your definition. Write that down. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. In each figure below, line L is a common tangent to circles F and G. So you can see how we could have two circles, and the tangent line is just going to touch F here and then touch G here. Or you could have one where it's just like those circles are just touching at one single little point, and the tangent line is going in between them. Okay? So that's how that could look. I don't know if your homework asks you to do this, but if they ask you to sketch a tangent line, you could do a couple of options, right? Like you could do something like that, or you could go the other way. Mine aren't perfect. You know how I am. Tangent line here, right, would be more like this instead of going through. And this one's pretty easy if you can get it. That one was okay. But it should just barely touch, like that one in the middle. No bueno. So try it again. That's hard with the mouse. That's so bad. It's just so bad. Like, I don't think anyone's ever drawn anything worse ever. But that's all right. We're cool. You guys can do it better than I can. I'm just here to guide you all. You're all going to be smarter, more successful than Mr. T, which is the goal. And that's what I'm trying to help you do. All right, ready? Here we go. Theorem number 1 for this section. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency, okay? So it's an if and only if. So remember, this goes both ways. If we know it's a tangent line, we know it's perpendicular to the radius. If we know a segment line out here is perpendicular to the radius, then we know it's a tangent line, okay? So this goes both ways. This is going to give us some options. I think you know what might happen. Right angles, everybody's favorite. So there's your theorem. Super important. I'd write that down. And I know we're almost done. We're probably fading. We're probably losing hope. We're probably like ready to be done. But let's stay focused. Still got a final. You got this. We all good. So if we want to determine if this is tangent, we want to determine, is this a right angle? Is this a right angle? We don't know. How could we check? Yeah? Who is that? I can never remember who I'm supposed to call him. Santino, what do you got? Oh, we can do the converse of the Pythagorean theorem? Yes, we can do the converse of the Pythagorean theorem. Okay, but we seem to be missing something. 9 is just right here. This is the hypotenuse. It should be the longest. Oh, there's another radius. Yeah, Annika's right. There's another radius. This is 8 here. So this whole thing is 17. Okay. Ah, now we're cooking with gas. All right, so now we got to do our little 8 squared plus 15 squared. Does that equal 17 squared? Oh man. Okay, this is 64 plus 225. God, we just talked about 17 squared in another class. Is it 269? Calculator time. Always got to have a handy dandy. Handy dandy calculator. I think it's 269. But let's see. Oh, 289. Sorry, kiddos. 289. And guess what? That means that they are equal. We get 289, right? Equals 289. Give that the old checkaroo. Check that off the old box. Check. So it is a right angle. So yes, it's tangent because we get a right angle here. So we got a tangent line, KL. Pythagorean theorem is just never going to leave us. Never going to give you up. Never going to let you down. All right. What's next? Oh, here we go, kids. Okay, so given that segment JH is tangent, it is tangent. There's a tangent line here, so this is a right angle. So we can do Pythagorean theorem. This looks like an interesting setup, though. You guys see where we're going here? So we get x squared plus 12 squared equals, what is our hypotenuse? What is our hypotenuse? What do you got, Josh? X plus 8 squared? Yes, sir. Yes, sir. And x plus 8 squared, right, is just x squared plus 64. Is that right? Is that right? No, it is incorrect. Foil it, kids. Foil it. I'm going to teach you one thing. It's going to be to foil. Hold on.